Good morning students. This is class 9, subject science, chapter 8, motion. It's your lecture number 4. In today's lecture, I would be discussing graphical representation of motion by distance time graph. So let's start distance time graph. The change in position of an object with time. It can be represented by distance time graph. In this distance time graph, we take time along x-axis and distance along y-axis. This is distance time graph. Distance I am taking at x and time as t. So we can also say xt graph. So in distance time graph, time it is taken along x-axis and distance is taken along y-axis. Now first case is if a body is at rest. Means there is no change in position of that body. Before starting drawing any graph, first of all draw a table. It was distance time graph, so write t for time, x for distance. Time interval, it will start from 0, 1, 2, 3 and so on. Now coming to this distance. You can take any distance because the body is at rest, means there is no change in position of that body. It is at constant place. Now I am considering the constant distance, let it be 5 meter. You can take 2, 3, 4, anything. I am taking 5. So when the time interval was 0, the distance was 5. When time interval is 1, it was constant, it was again 5. When time interval is 2, again 5 because the body is at rest. 3, 5. So we have got now the tabular form for time and distance. Okay, now let's start plotting the graph. In graph, time is taken along x-axis and distance is taken along y-axis. Okay. Now you can write 1, 2, 3, 4, 5. Sorry, this is 4. You can write down 1, 2, 3, 4, 5 according to this, and you can take distance since it is 5 only. So 5, 10, 15 I have taken. You can take 0, 1, 2, 3, 4, 5 itself. Now when time is 0, distance is 5. When time is 0, distance is 5. When time is 1, distance is 5. Time 1, distance 5. When time is 2, distance is 5. Time 2, distance 5. When time is 3, distance is 5. Time 3, distance 5. So after you have got these points, join these points. After joining these points, you will obtain a straight line. You will obtain a straight line, and this straight line it is parallel to time axis or x-axis. This straight line it is parallel to time axis. So if a straight line is obtained parallel to time axis in distance time graph, what does it indicate? It indicates that body is at rest. It indicates that body is at rest. So this was the first case. Now second case is if body is in uniform motion. The motion is uniform. Again draw a table. Time t for time, x for distance. Time interval 0, 1, 2, 3, 4, 5 and so on. And now coming to x. Initially it was at 0. I have considered 0. Now in 1 second it travels 5 meter distance. I have taken this 5 meter. You can take 2, 3, 4, anything. I have taken 5 meter. So in 1 second it travels 5. In the next 1 second it travels again 5. So it will be 10. In the next 1 second it travels again 5. So it will be 15 then. So time is 0, distance is 0. Time is 1. 5 meter it has travelled in 1 second. In next 1 second it has travelled again more 5. So 10. 5 plus 5, 10. In next 1 second it has travelled more 5. So 10 plus 5, 15. In the next 1 second again 5 plus. So it will be 15 plus 5, that is 20. So you have got these tabular form. Time and distance. Now let's start plotting the graph. Again time interval on x-axis and distance on y-axis. Now I have written 1, 2, 3, 4, 5 or 0, 5, 10, 15, 20 according to this, which is convenient more. So let's start. Time is 0, distance is 0. When time is 0, distance is 0. When time is 1, distance is 5. Time 1, distance 5. When time is 2, distance is 10. When time is 3, distance is 15. When time is 4, distance is 20. So we have obtained these 4 to 5 points. Now join these points. After joining these points, you will obtain this straight line. You will obtain this kind of straight line. Now, on this line, consider any 2 points anywhere. You have to consider 2 points anywhere on this line. I have considered this point here and this here. I have considered 2 points. This one and this one. Now, draw perpendicular from both the points on time axis and x-axis. So I have drawn from here to this and from this to x-axis also. Now again from here, from this point, again on time axis and again on x-axis. Okay. Now after drawing the lines from these points perpendicular on time axis and x-axis respectively, join this line. Join this line. Okay. Now up to this time, this is time axis. So up to this time I have named T1 and this up to this time I have named T2. Similarly here, up to this point I have named X1 and up to this point I have named X2. Okay, T1, T2, X1, X2, time interval 1, time interval 2, distance 1, distance 2. Okay, from these 2 points. Now, when you will join this line, you will obtain a triangle, a right angled triangle. Okay, now make this angle and I have named this theta. You can also name like this is like this, theta. So now calculate this line and this line. See how to calculate this. The total is x2 and this one is x1. So what is this? x2 minus this x1. So this is x2 minus x1. Similarly here, time interval up to this, from this point to this point it is T2 and from this point to this point it is T1. Now we need to calculate this line only, means this. So it will be T2 minus T1. So T2 minus T1. Now you know this line, you know this line. So what is the formula of calculating velocity? Formula velocity. Velocity is displacement upon time or distance upon time, one and the same thing. Now what was the distance? x2 minus x1 divided by what was the time? t2 minus t1. So x2 minus x1 divided by t2 minus t1, that is equal to tangent theta. That is equal to tangent theta. Now many of you students, you do not know what is tangent theta. So let me start again with this tangent theta. What is this? This is a triangle and you have named this angle theta. Okay. Now opposite to this angle, this side, we call this side as perpendicular. Opposite to this angle, this side is perpendicular and then this one is base. This is base and this one is perpendicular. So what is tangent theta? Perpendicular upon base, means this side upon this side. Okay. So velocity is distance upon time and this perpendicular upon base, that is tangent theta. Theta is the angle, tangent theta. So this gives the slope of this graph. Means in distance time graph, this slope, it gives velocity. It gives velocity. So a question can be asked, in distance time graph, what does the slope tells if the body is moving in uniform motion? So the slope tells about velocity. So this was about second case, if the body is moving in uniform motion. Now the third case, if the body is moving with uniform acceleration. If the body is moving with uniform acceleration, means there is some acceleration that is constant. I have considered 2 meters per second that acceleration. You can consider 5, 6, 7, anything. I have considered 2. I have considered initial velocity 0. You can take 1, 2, 3, 4, 5, whatever. You will obtain the results, don't worry. Now again draw a table. Time interval, x-axis, time interval 0, 1, 2, 3 and so on. Now you need to calculate this x, means distance. You know A, you know u and t. You need to calculate s or x, one and the same thing. S means x. So which formula you will use? Second equation of motion, that is ut plus half at square. Now substitute the values. Initial velocity is 0, so ut becomes 0 plus half a is to t square. So 2 cancel with 2. So s is t square. Now when time interval is 0, what is x? When time interval is 0, 0 square, that will be s, means 0. When time interval is 1, what is x? 1 square, that will be 1. Okay, 1. Time interval is 2, 2 square 4. Time interval 3, 3 square 9. Time interval 4, 4 square 16. So you know these, you can calculate this. After drawing this table, start plotting the graph. Same, time on x-axis, distance on y-axis. Now, when time is 0, distance is 0. When time is 1, distance is 1. Time is 2, distance is 4. Time is 3, distance is 9. Time is 4, distance is 16. From the table I've drawn this. Now you have obtained these points. Start joining these points. When you join these points, you will obtain a curve which bends upward. There is a curve which bends upward. So when there is a curve bending upward, it means acceleration is positive. When a curve is obtained which is bending in upward direction, so acceleration is positive. Now if this curve it is bending downward, it means acceleration is negative. If the curve is bending downward, it means acceleration is negative. You can see from the graph also. This curve, it is bending in downward direction. So in this case, the acceleration is negative. So are you clear about the three cases in distance time graph? First, when the body was at rest. Second, when the body was moving in uniform motion. Third, the body was moving with uniform acceleration. So these are the three graphs for distance time graph. We will discuss velocity time graph tomorrow. So what is question number 1? Write down. What is the nature of distance time graph for uniform and non-uniform motion of an object? Question number 2. What can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? So these are the two questions for your homework. That's it.